Hello everyone and welcome back to another professional prep video. In this video we're going to talk about calling non-void methods and string objects. And so let's get started. So non-void methods, we've already touched on this, but a non-void method is a return method. There are void methods and return methods, aka methods that return a value. So for example, we have 3 of them right here. A lot of these get methods are going to be, or accessor methods as we'll call them later, those are going to be our return methods. And so you can see their structure right there. And I should tell you right now, return methods, calling them, they should be used in statements that use the value of the return method. Of course, the setCar method performs this, or it prints something, but these return methods just return something in the end. That's their last statement always. So you should call them in statements that use that return. So what I mean by that is, here you can see I've used all 3 of these methods, and I use them in a print statement. And when I run that, you can see I get these values here. However, what I mean is, say that we comment out these print statements for now, right? And let's just call one of these get methods as it is, Toyota.getPrice. So this is going to return the 7,000, but you can see that this is the new thing of what we just ran. You can see it doesn't really print anything, and that's because we didn't ask it to do anything with the return value. Here we're asking it to print it, so it'll print it, but here we don't ask it to do anything. So while it's not a syntax error, you should be using your return methods in statements that use the value, or you can always assign it to a variable or something. So there's an example of that. And the last thing I wanted to say about these non-void or return methods is that the data type of the return value has to match the data type in the heading of a return method. So let me show you an example here. Let's uncomment the getPrice method. So the getPrice method returns a double. Price is a double. That's why we see this double in the heading. That indicates the data type of what we're going to be returning. Is all-wheel drive returns a Boolean, true or false? So let's say that we change double to Boolean. So now we have price being returned, which is a double, but by the heading it indicates it's going to return a Boolean statement. And sure enough, that's going to get us an error right there with return price. Double cannot be converted to Boolean. That is why we need to use double here, and that needs to match, and then we're going to print out the 7,000 just like we want. So that is all that I got for you on non-void methods right now. So let's head into the world of strings. I'm actually going to get rid of this code here because we're going to start with a fresh plate. So let me just get my class in. Now you understand the class portion of it, and this is the main method. You can understand that as well. So now that makes more sense. Alright, so let's start fresh here and work on some strings. So as far as strings are concerned, they're just a sequence of characters. I already talked about that. But something important to know is that strings are actually reference types. And there's a few ways here that we can create or instantiate or construct a new string object. So the first one is what we call the literal string. So string, I don't know, let's just use lemonade equals lemonade. There we go. And then another way we can do this, strings are reference types, meaning that you can use string objects. So declare it similar to how we declared an object. String class, so string lemonade1 equals new string. And now we can type in whatever we want. Let's just put lemonade again. That's how we would use that. And we can also use, we can just use an existing object. So string lemonade2 equals new string My bad for the spelling error. And here we can just use lemonade 1. Those are the ways of instantiating our string objects. You could see any 3 of those as we move forward in this course. As you can see, there's no errors there. So now let's head into what we can do as far as comparing these go, which you're going to have to do in a lot of code segments. And this is going to spark a new discussion for us here. So let me just declare a couple of ints. Int lemonade equals 7, and int, I don't know, let's just follow, actually, let's use colors. Int red is going to be 7, int blue equals 7. So these two are obviously going to be equal, and let's declare 2 string objects and use our new operator for both of them. So string green equals new string, let's say green. There we go. And let's get one more in here. String yellow equals new string. Let's also put that to green. So as you can see, the 2 primitive data types store the same value, and these 2, green and yellow, are both strings that have green, ironically, for yellow. So now we're going to use our equality here. So let's do this. Let's print red equals blue. So this equals, I said that's our equality operator that's going to compare the values of the 2. And it's going to return true. Or I should say it's going to print true if the 2 are equal. False if not. So let's run this. Both of them are 7. So indeed, oh my bad. I need to end this class. That's the error there. There we go. This should work now. So yeah, sure enough, we get true because they both store value of 7. So now let's run the same thing for our strings here. And we're obviously expecting another true statement because both green and yellow store a value of green. So let me uncomment that. We're expecting true, but no, we get false. And this is very interesting at first. And let's go over why this is. So one thing you should know is that we have 2 addresses to store these values. We have a physical and a logical address. And let me start with this. Objects that use the new operator right here. The new operator is vital. It declares that memory that we need for the object. So objects that use that new operator have both a physical and a logical address, while primitive data types such as int red and int blue only have a physical address. So here's the thing. A physical address contains a reference to the logical address. That's why, say that we want to print green. That's why this right here is going to display this. Or actually, oh, my bad. No, wait, let's not do that. Let's just say we have, let's just use this for now. So the memory address is going to say, what I was going to show, by the way, right there was the fact that a memory address would be printed, which we saw a few videos ago in our introduction, first video to OOP. However, the string method has a redefined print class. We'll get into that more later, and that is why it prints green instead of a memory address, just so that we're clear on that right now. But anyway, so back to physical and logical addresses. The physical address contains a reference to the logical address, and that's usually that memory address that you see. The physical address contains that reference, which is going to be the memory address in hexadecimal to where you can find the logical address. and that logical address contains information about the string, the actual value of the string. So, in other words, the logical address is going to contain green here. So, let's explain what we just saw with the true and false. The double equals test for equality at the physical address, and obviously we're going to get that for red and blue right here. Those two are going to be true. These are primitive data types that only have a physical address, and that is why the physical address stores the value of 7 for these primitive data types, and that is why we got the double equality operator, which tests for equality at the physical address, to show them as equal. You see this true here. However, green and yellow are objects or reference data types, and this equality is going to test for equality at, well, the physical address, which is not going to be equal because these are two different objects. So those two are not going to be equal to each other there. They have a different memory address and therefore a different physical address. That is why we get false here. It's very interesting. However, there is, lucky for us, a dot equals method. And we're going to get into string methods more in our next video, so stay tuned for that. However, there is a dot equals method. We can say green dot equals yellow for strings. And what this method is going to do is it's going to test for equality at a logical address. And sure enough, when we run that, we're going to get true, which you see here, because these two logical addresses of green and yellow both store green, and that is why we get true. And I should say, though, if you have a literal string, like say we have, let me comment, these. Say we have string green equals green, and we have string yellow equals green. I should say that this will work with the double equals. It'll display true. And the reason for that, you can see it right there. And the reason for that is the fact that we did not use the new operator here. This is a literal string, so it'll compare at the physical address, which is green. You need to use this new to create a new object. And then we run into the whole logical address and dot equals. And the last thing I'm going to offer you guys for the end of this video is going to be the fact that string objects cannot be altered. And what I mean by that is if you do try to alter a string object, then it creates a new string object with a different memory address. That's just something to keep in mind, that string objects are immutable, but no examples for that or anything. Just something to keep in mind. That's all that I have for you for this video. Thank you very much for watching. I will see you next video to talk more about string methods. Thank you, everyone.